This is gonna keep you up while you sleep tonight.
No, it isn't.
Hollow moon theory.
This video has 6.5 million views and over 500,000 likes. I'm not mad. I'm just disappointed.
Our moon really doesn't make sense when you look at the facts.
Only if you really don't understand them.
Moon is about 25% of Earth's size. Despite this, the moon is only 1% of Earth's mass, meaning it is way lighter than it's expected to be, and we really don't even know why.
The implication here being that because the moon is 25% the size of the Earth, it should also be 25% the mass. That's not how density or gravity works. 1% Earth mass is exactly what you would expect for a moon the size of ours. In fact, all of the other large moons in the solar system that are around the size of the moon are also around 1% of the Earth's mass. Nobody is confused by this or ever has been, just to be clear. Well, somebody is.
Our moon's orbit is way closer than that of any of the other over 400 moons in our solar system.
No, that's actually not true at all. Neptune's moon Triton is closer in absolute distance to Neptune than our moon is to us, but that's not even the right way to think about it. See, the important thing when it comes to a moon that's orbiting a planet is how close it is relative to the size and density of the planet, and that's because of something called the Roche limit. If a moon gets too close relative to the planet's properties, then it'll break up. Actually, how we think Saturn got its rings. A moon got too close, it got tidally broken up and then spread out into a ring. But the appropriate way to talk about a moon's distance from its planet is not in absolute distance, which it's not the closest anyway, we already showed that. It's to think about its distance in planetary radii. Relative to the size of the planets, our moon is 60 planetary radii away, whereas Jupiter's closest moon, Io, is 6, Saturn's is 20, Titan, and then Triton is 14. So you're just wrong on all accounts. Not only is our moon not the closest, it's also not close at all for the size and mass of our planet.
It also has a near perfectly circular orbital path. We don't see this on any other planet, which all have moons with wildly eccentric orbits.
This image that he's showing actually does show that a planet like Saturn has lots of moons that have these wild eccentricities. But if you look in closely here, you'll notice that some of these are quite a bit more circular. One in particular I want to focus on is Titan right there. Reference, our moon has an eccentricity of 0.054. That means it's very circular, but not perfectly circular. If you want to know what eccentricity is, check out down here. It's just a measure of how elliptical an orbit is. If it's close to 0, it's a circle. If it's close to 1, it's very elliptical. It'd be like a straight line. To be clear, any number that is smaller than this is more circular. Here we see the eccentricity of Titan, which is shown in the image of 0.02. Now, I know that everybody is not a math person, but you know that 0.02 is smaller than 0.05. In the very image that he says no moons are more circular in their orbits than ours, there is an example of a moon that is on a more circular orbit. Like you're not even trying anymore. Where's your heart at?
Craters on the moon are all virtually the same depth, no matter how big or small they are.
We have a plot of the diameter and the depth of craters on the moon. You'll notice that there's some sort of linear relationship here. That tells you that as the diameter increases, the depth increases. I mean, this is just the opposite of what he said. Why are you lying to us? You gotta stop lying to us. We want to trust you, man. Help us repair this thing.